Hello, welcome to another Space Salon discussion hosted by the Atlantic Council's Geotech Center. My name is Dr. David Bray, the inaugural director at the Atlantic Council's Geotech Center, and I'm excited to host a very august panel today to discuss why we need to emphasize cloud computing services in space and what these services provide the world. We're going to have some interesting insights both on how the rapid innovation changes in this space impact government and business services, and more importantly, what these services provide to the public. I'd like to go first to Clint Crozier. Clint, could you first introduce yourself and then discuss what does linking cloud and space capabilities give us, and what does it allow communities to do that was not possible before?
Sure, and David, thank you very much. I appreciate the Atlantic Council for the opportunity to have this discussion today. It's a really important discussion. I'm joining AWS, Amazon Web Services, after 33 years in the U.S. Air Force and spending the last 18 months as the lead planner and architect of the stand-up of the U.S. Space Force. So have spent my whole career flying satellites and launching rockets, and I'm happy to be with AWS today. But that question is so great because how we can link the cloud to space and make a difference is the very reason that AWS stood up this new aerospace and satellite team that I lead. In fact, Amazon recognized the growing utility of space. More and more applications, more and more capabilities are migrating to space. We use space more and more each and every day. And so we recognize that the tools and capabilities of the cloud could have an enormous impact on the way we operate space and being able to move space forward to the future, whether it's national security, whether it's scientific research, whether it's economic prosperity. We live in a really exciting time where we're going to triple the number of satellites we launch into orbit over the next 5 years. And we've gotten to a point where we're bringing down petabytes and petabytes of data a day, right? And just for those of you that don't want to do the math in your head, a petabyte is 1 million gigabytes. And we're bringing hundreds of petabytes a day down from space. And we've gotten to the point really that you can only make useful information out of that by operating on the cloud and all the capabilities that the cloud provides. So we're all about helping our customers make quality decisions based on this data. And we have to have an analytical process and platform to be able to make sense of it all.
Excellent. And if I could ask you a real quick rejoinder, Clint. So with these transformative capabilities, I mean, is it just a case that this now means we have to think about more storage? I mean, does this mean processing at the edge? What does this mean for impacts on the ground, if I could ask?
Well, it's all the above. So think of any satellite provider that's bringing down data, again, for scientific research, to support agriculture operations, to support disaster response or relief efforts, any of those things. When the data comes down, we have to put it somewhere, right? So that means storage capabilities. We also need to be able to make sense of it, and between artificial intelligence and machine learning and data analytics algorithms, right? You want to be able to apply those as quickly as possible to be able to make sense of it. And so just all sorts of ways that we would use the cloud to help manage those processes. It's all about enormous volumes of data, more than we can manage given our old processes.
Excellent. Well, thank you, Clint. And I'd like to now pivot to Peter. So Peter, maybe sort of real quick, the same question, if you could introduce yourself, and what does this really mean in terms of transformation of how governments or businesses, I mean, what does this give society that's not been possible before?
Yeah, no, of course. And David, thank you again, and the Atlantic Council for putting this together. This is a great opportunity. My quick background, I am the head of space policy at AWS. It's the same title I've had in government as well. I was the director of space policy for President Bush and for President Obama in their White Houses, and spent a lot of time in the Pentagon, where I think the first time I met Clint Crozier may have been a lieutenant colonel or a colonel. So we have a long history in the Pentagon on national security space programs, and I've spent a lot of time in the commercial side as well. So to get to your question, though, I think it's a really exciting time for both space and cloud and computing, because all the missions we're talking about doing, I don't care if you're a commercial customer or a government customer, all of the amount of data that we're pulling in to do things like national security missions, weather, disaster monitoring, terrain mapping, we talked about wildfire, all the global applications. You just can't do them the way we're doing them. We've done them in the past. So Clint talked about a petabyte of data, and we're taking down petabytes a day from space. So he talked about it being 1 million gigs. But let's put it in a little bit, familiar perspective a little bit. 1 petabyte is 11,000 4K videos. It would take one person 2.5 years nonstop watching to get through all 11,000 videos. To manage that kind of data that's coming down a day is impossible unless you're using cloud to collect the data and also compute and analyze the data. You know, I've got a picture of a garlic bulb over my shoulder. I'm from Gilroy, California, an agriculture town, right? What we're doing right now in space, it's the same as building a farm, getting the land, plowing it, fertilizing it, growing a crop of garlic, and then getting one bulb out of that entire thing. And so being able to use cloud and compute allows us to use the data to solve all these problems. So I think it's a really exciting time for what we can do in the future.
That's really putting in perspective the massive amount of data and how it can be used. I guess, if possible, Peter, as a quick, so what kind of analytic processes are available? Is this a case where, you know, people can build on top of the data or build on top of a platform? How do we actually sort of see innovation in the analytic space, given that we're going to have these sheer volumes of data that's going to be available?
Yeah, so I think that's probably one of the unique things that cloud and compute gives us, is that you're able to build on legacy capabilities. So we're not throwing everything away that's come before. We can build on top of that while at the same time evolving to a future architecture that really is able to integrate. Again, my national security, you know, side is showing the multi-ints is what I'll say. So pulling in data regardless of where it came from. I don't care if it came from space. I don't care if it came from Twitter. I don't care where it came from. It's all about getting the right information to the right people at the right time to make good business decisions, good national security decisions, good economic decisions. And that's really what we can do in this environment without having to throw away everything we've done in the past.
Excellent. Well, thank you. And now I'd like to turn to Dr. Divya Chander. So Divya, you're a longtime friend of the Geotech Center and Atlantic Council, and also a bit of a polymath because you do both space, you do data, you do medical, you're a practicing physician. I guess I would ask your perspective, you know, how do you see this changing what's possible? And if possible, could you also share a little bit about your thoughts about how we might use it to have a better sense of, say, an immune system for the planet or public health, or how that changes how we do the practice of public health?
Yeah, no, thank you. Thank you for having me on this panel. I know I might seem like the odd person out, being a physician and a neuroscientist, but well, a couple of things, David, to speak to what you said. I think that Clint and Peter set us up really nicely because they spoke about the sheer volumes of data that are actually coming from space, and that we need some sort of a network fabric to be able to integrate this kind of data. And specifically, when we're thinking about it in the context of COVID, that becomes really, really important. We've been using data that comes from space actually for a very long time for things like Earth monitoring applications and disaster warning. And we need the equivalent to tell us when we may be actually encountering, for instance, new pathogens. And we can do this by observing not only the Earth from space, but just things that people never thought about, things like animal migrations and human migrations. And as these guys have set up really well, we need a way to bring in multiple data sources so we can do essentially sense making. That's what I've been hearing. And one other thing that I have been doing is actually working with a company called Plexus to create a new data fabric that can sit on top of any cloud. And what this data fabric enables us to do is to wrap data that's being generated or produced at the source with sort of a security wrapper. So you can basically identify each security payload and bring those into the system. It also enables us to do something we have a lot of trouble with in medicine, which is how do we share data amongst different data sources or silos? So we can label data according to international standards, we can promote interoperability. And finally, there's, I think, one last idea to introduce here, and that is how do you actually authenticate data sources that are actually coming into the system? And so we have this sort of federated identity management system that we've been developing that will enable us to talk to data providers at the edge, no matter where they come from, no matter what kind of data sources they are. We might potentially even be able to talk it to entire networks so that we could actually integrate the intelligence of each network as they are integrating intelligence. And I see this as being really, really important to integrating these petabytes of data that these guys are talking about coming from space.
If I could real quick ask you a great rejoinder onto that, because I think that sets the scene as to how this can be used for medical and public health purposes. And you talked a little bit about the challenges of interoperability. Could you tell us a little bit more about the challenges in hospital settings in particular with trying to actually make sense of data and actually bring it together? I mean, is it, I mean, I'm going to ask this rhetorically because I know it's not the case, but is it as simple as, can't cardiac share with anesthesiology, or are there other challenges that are there?
Yeah, you know my pet peeve. Okay, so I worked at Stanford Hospitals for 8 years, and I'm in the Department of Anesthesia, and we couldn't easily talk to people literally in the department next door in the ICU. We all have different conventions. Our electronic medical record, we actually had a person who was within each department who would create an entirely separate instance of Epic for each department. And the end result is that something so simple and silly as trying to figure out what somebody's pulse was difficult to share, because I might label it pulse, somebody else might label it HR, someone else would label it heart rate. And then these data sources may even come from different monitors, like an electrocardiogram or the pulse oximeter. And just bringing them in from one system was difficult enough. Now we have to do that across hospital systems. We have to do that with brick and mortar outside, with telehealth providers, with the US government, which by the way has one of the oldest, if not the oldest, electronic medical record system in the country, which is CPRS. I remember using that a lot at the VA hospital. But it's actually fairly nightmarish. And if you talk to anybody who does research and wants to do sense making, for instance, apply AI to these reams of data, they have to figure out ways to actually talk to other data producers. And that's been a really huge problem for us in healthcare. For coronavirus, by the way, people have had a lot of difficulties just analyzing really basic demographic data coming in from all over the country to make sense of what's happening.
Well, thanks for that, Divya. I'd now like to turn to also a longtime friend of the Geotech Center, Dr. Joe Bonneville. Joe, thanks for joining us. Joe, could you give us your thoughts about, once we have this fairly impressive, transformative capability of using cloud computing and how that changes how we receive information from space, what might be other applications we could use this for?
So I think, speaking from what I would say would be a futurist, I would say a futurist, and things that I think that we really want to look at are things that everything that's been going on within our kind of our weather system and health emergencies and things on that nature. So if we're able to process that information in a timely fashion and in situ, we can get on the ground to track things like pandemics. We can get on the ground to track tsunamis and death tolls and things of that nature, so that we can get directly to saving lives in a very immediate and expedient fashion. I think that's kind of one of the things that kind of transforms this technology with the Internet of Things and the ability to really get to data at a lightning pace, if you will. It allows us to do, you've seen commercials about doing surgeries from 1,000 miles away and all those other types of things. But for me, I think in a DoD perspective, supply chain and logistics and things of that nature become invaluable when you're able to do it immediately on the ground. So it's almost like just-in-time manufacturing, literally just in time. So I think that's the number one thing I see coming out of cloud computing and kind of the Internet of Things on space.
Excellent. And maybe to build on what Divya was just talking about in terms of the challenges of standards, I often say standards are like toothbrushes. Everybody wants one. They just don't want to use somebody else's. I can imagine supply chains, there's also the challenge of interoperability, but maybe that's solved in some degree because space is about location and time. So I guess maybe I'd be interested in your thoughts, Joe, about, as you think about the logistics and coming from a perspective, again, that you're independent, not representing the Department of Defense, but you've seen some of the challenges, what might be some of the areas where you could see supply chains could be improved using space-based observations?
So the thing is, coming from a DoD perspective, we move a lot of very big things across the planet. You start thinking about, everything from tankers to jet planes to kind of the large scale infrastructure. I think that's a challenging question, because do we focus on, so I guess my point is, do we focus on the small scale or the large scale, right? So on the small scale, I do believe the interoperability and the ability to say, okay, this particular object is located at this place on this point in time, and we can get it to this place. We can forecast very effectively using IoT. But on the larger scale of things, we lose some of our competitive advantage when we move very large things. So we're almost masking things at that point. So I don't have a good answer for you, David.
All good, Joe. I'm really glad to also have some guests that are joining us from Australia to share their perspectives in this important space. I'd like to first go to Paul. Paul, could you real quick introduce yourself and then share your insights into what cloud services can do for us as they transform space capabilities?
Yeah, sure. Thanks, David. Hey, my name is Paul Grambauer. I work for a company called Fireball International. We provide early wildfire detections as a service. So my role at Fireball is to interface things like application development, but also data acquisition from satellite and ground sensors, and bringing all that together into our data pipeline. So as I mentioned, we do this using ground-based sensors, but also air and space sensors. So fundamental to the success of Fireball is the timely acquisition of data. Combining that with years of research that the team's done in fire model patterns and behaviors. So from ground-based sensors, we currently acquire from more than 500 cameras just in the California region alone. And we normally polling these cameras once every 10 seconds. So you can imagine that's quite a lot of data. It's actually 2.5 million images of data being scanned for fires per day. So our satellite data is processed, and we store this in our S3 bucket, typically within 5 minutes of acquisition from the satellite itself, which allows us to augment our ground-based sensors. So it's kind of like if you tell me something's right, then you're a trusted source, and I'll believe you. But if someone else tells me that, I'm likely to believe it even more. So that's the idea of augmenting multiple sensors. So minimize latency between data acquisition from these source sensors and our analytics platform. It's critical for us to deliver near real-time detections. So we use cloud services, that's more specifically AWS, because they provide us with that on-demand horizontal scaling of infrastructure that we need to support this big data analytics capability. And so by using these cloud services, we can reliably deliver cloud detections on a global basis every day, 7 days a week, typically within a 2-minute range. So it's a great service to be part of.
Excellent. And real quick, as a quick rejoinder, so it sounds like you're triangulating data from multiple sources, space being one, but also what you have on the ground. And is it a case where it sounds like you're also doing fire spotting as well? So it's not just once you know there's a fire, but this may actually be warning that says in this remote region there's a fire, and so you may actually now need to get assets on the ground to deal with it?
Yeah, that's correct, Dave. It's a fundamental part of what we do is the rapid notification to these emergency services. So one is we're using our AI capabilities to detect smoke in its smallest size, so before it gets too large and requires significant resources to extinguish. So we want to get really small smoke really fast, and then let the relevant authorities know as fast as we can, so that they can deploy their resources to act on that fire.
Excellent. Next, I would like to welcome Dr. Fang Yang. Fang, could you please introduce yourself and describe your program and what you're doing when it comes to data sets, orbital cloud capabilities, and their potential benefits to communities?
Thank you, David. So my name is Fang Yuan. I'm an Earth observation scientist. So I work in the Digital Earth Africa establishment team. I co-lead the product development team in the program. So Digital Earth Africa is a program that what we're trying to build is a platform that try to provide free and open Earth observation data sets for all of Africa, and help to turn them into information products that can be used to assist decision making. So what this means is that we work with upstream data provider to make sure that we have a reliable inflow of data set. And we also work closely with Amazon Web Services because they host our data, a lot of them in the public data sets program. And also we build infrastructure to process and distribute our data in AWS. So the other part of our program is we work with institutions and regional centers in Africa. Eventually, the program is going to be run in Africa by Africans, but in the establishment phase, we're working with partners there so that we can make sure that we focus on addressing key challenges that matter most to the African communities. So in our product development work, we aim to co-design, co-develop, and co-validate our products with partners and users in Africa. And the open data and the cloud technology really means that we take a quite different approach than traditionally done in product development space. So for example, we have been working with our partners across Africa to validate our water mapping products. We are working with partners and stakeholders to produce a continental-wide cropland map that can help address food security challenge. So our product development cycle is very flexible. So in the kind of the concept development phase, we take advantage of the open data sets and cloud native format, so we can actually experiment with lots of input data sets that's available out there. And because we have a shared analysis platform, we use Jupyter Lab Sandbox, where we can explore with our users different use cases, co-design our products with our partners, and quickly try different kind of method, see which one works. And we then use scalable compute in AWS to process large amount of data at regional and continental scale. And likely we'll have to do it a couple of times through the development cycle. And finally, our intermediate and final products we share with users through many different ways using the cloud technology. We allow users to visualize them, analyze them in place in a Jupyter Lab environment, and through web services. So that means we continuously tune and refine our products and with users, and also try to drive additional product development using these products we have already produced.
Excellent. And what I liked about what you're describing is it seems like you're taking all the principles that we know from agile software development, but applying it more to data lifecycle and involving stakeholders in the data processes. Is there anything that you find that needs to be custom tailored, given that data is a little bit different than software, or is it basically the same? And then the other question I would ask is, how much of a challenge is it trying to get interoperability across different data sets that you pull in for these efforts?
Yep, so I have to take one at a time. So the data, sorry, can you get to the first?
Sure.
Well,
I'll repeat the question to you, no worries. I'm here. So my first question for you is there anything unique about trying to translate agile software development to the agile data process when you're involving multiple stakeholders?
I think the principle, as you said, the principle is quite similar, and we're trying to be very adaptive. And so we actually use agile style project management. So I think it's really just focusing that. So agile is not a prescriptive thing. So we use the principle, but we apply it in a way that we adapt it to what we need.
Excellent. And so then my next question would be, if we think about you're bringing together different data sets, some data is maybe in one standard versus another standard, how much is a challenge of interoperability with trying to do this? And what are ways that you find that you can solve this, if there's any?
Yeah. So this is actually something we try very hard to work through. So there are two fronts that we're working on. One is on the input Earth observation data. We work with this Card4L COS analysis ready specification. So we want all the data to be processed to a common or agreed standard so that users can take them and readily apply analysis on them. And that's why we want to work with data providers that make sure that these data comes in a standard that everybody understands. And the other part of this is we want all the data to be in cloud native formats. So raster data in cloud optimized geotiff. We apply stack metadata so that things can work. Yeah, interoperability is very important so that we can work all these data sets in a consistent way.
Excellent. Thank you for that, Fang. I really appreciate it. Clint, speaking of interoperability, I was wondering if I could ask you, are there any lessons learned from your time at Space Command that translate into what you're now doing with the private sector and AWS as institutions think about how to use these new capabilities?
Yeah, I think it's really sort of, as we said at the beginning, it's about being able to make sense of the data. You know, one of the lessons I've learned over 30 years of, operating space things, flying satellites in particular, is the ability to make sense of the data, right? There have been plenty of times in the past where you're working an operational problem and the answer is somewhere in the data somewhere. But how you extract it out, right? So part of it is just putting the data in a useful form that you can make sense of it, you can manipulate it, you can analyze it, you can move it back and forth. It can be shared, as Divya was saying, that it can be shared across different organizations. That's one part of it. But the other part is the cloud allows us to bring capabilities to bear, such as pattern recognition, such as change detection, such as real-time data analytics, identifying anomalies or trends within data. Those are the kind of things that really allow you to take those large volumes of data and make real-time sense of them and apply them for operational or real-world decisions. That's the real key. And I know here in a few moments, our friends at Fireball are going to talk a little bit about the way they use artificial intelligence and machine learning, bringing data down through AWS system to make sense of what they see on the ground, which I think will be really informative.
Excellent. And great segue, by the way. Kudos. So now I'd like to probably go to Divya, and then I'm going to go to Peter and drill down a little bit more, because Clint sort of painted this great picture that there's a shelf life to data, that data is most relevant when it's at its freshest or its most recency. And so Divya, from your perspective, I know you're thinking a lot about how we can actually make sure we detect future outbreaks or pandemics better. What would you want to see as a physician in terms of possible information coming both from space and other data feeds that would actually help inform what you were doing? I'd be interested in your perspectives there.
Yes, I'll give you perspective on that, and then I even wanted to speak to something that else that Clint said about surgery in space and latency, because I've actually worked on that problem. But
as long as it's not 2 second latency, we're good to go, right?
No, there's some really interesting problems that come up. But let's go back quickly to your other question. What would I want to see? What I would like to see is things not having to go through a hierarchical vertical system in order for information to get out for us to act upon it. That's exactly what happened in Wuhan. It's happened before with other sorts of outbreaks. What I'd like to see is a much more sort of lateral decentralized system in which data that's coming from a validated source, I mean, perhaps we don't exactly know what to do with it yet, but it has a way or a capability of getting into the system without having to be vetted by people who maybe have political or economic interests in first evaluating the data and determining how it gets out. That's how you make use of just-in-time data. And again, I actually think that the authentication of those data sources and having trust in that authentication process with sources at the edge becomes really, really important. And then we can do all these really interesting sort of sense-making sorts of things once we have actually access to that data. The second thing we haven't talked about yet on this particular call, but it's going to come up, is whether you deploy the intelligence itself at the edge, or whether you actually bring the data into the center and aggregate it. And if you do bring data into the center and aggregate it, how do you actually preserve civil liberties and not turn into sort of this global surveillance state while you're doing that? And a lot of the solutions that people have come up with involve, to some extent, bringing data in, but injecting enough noise into the data so that it can't be truly identified. And that also brings in its own problems in terms of actually sense making and aggregating and deploying our machine learning algorithms on that type of data. And again, if you have the right security wrappers, you may be able to actually bring in data as it is rather than having to sort of noise it up. Mm-hmm. I'd like to just really quickly, though, go to this latency issue. So you may not know this, David, but I almost did become an astronaut back in 2004. I know that. That's why you're here, yeah. But I actually did work at Johnson Space Center for a little bit in space medicine and space life sciences. And this idea of being able to deliver care to the people who are working and exploring in space was a big deal. If there's some sort of an emergency in space, you can't really bundle them up and then just sort of set them on a reentry course for planet side in order to stabilize these emergencies. So I was looking to build critical care systems in space and deploy them. And one of the issues that we have is we have not enough skilled medical people in space because they're working lots of jobs. So a few years back, myself and another astronaut, we did a simulation for trauma with somebody who was in the Mars Desert Research Station. So it was sort of a Martian simulation. And we did it with the Concordia Antarctic Base, and we also did it with another critical care physician in France. And of all the things, the latency was absolutely killing us, right? So we were trying to get somebody to stabilize this person's hemodynamics, basically so that their blood pressure didn't go into the toilet, so their heart rate wasn't through the roof. We were trying to intubate them and get them to do some really basic surgical stuff. And so my takeaway from this is that you can't rely on sort of instantaneous communications. You're actually going to have to augment human skills bases and intelligence with a kind of machine intelligence. And that merger, in my opinion, can only happen with this kind of cloud-based service that we're talking about. So it actually increases our ability to move further and further away from the planet and also deal with emergencies as they arise.
Agree with you 100%, Divya, and you hit the nail on the head. That darn speed of light is the limiting factor. And so it's definitely going to probably be, at the end of the day, there's going to be intelligence at the edge once we have the ability to have, whether it's a drone doing a medical procedure or doing something else, maybe it's mining an asteroid. And that's going to require a cloud computing infrastructure that can actually support both the data feed, but also the intelligence at the edge, and then what the intent is being sent, but not the precision from wherever you are on the planet. So that now sets it up to Peter. So we've gone from everything from possibly preventing future pandemics to possibly drones in space. Peter, I'd be interested in your thoughts about, could you actually share a little bit more of some of the transformative thoughts that you're thinking about, whether it's from a national security perspective or from a civilian civil society perspective?
Yeah, thanks. Now I'm going to tie all this together.
Exactly.
No, I mean, these are all amazing, excellent points. And just briefly to touch on the machine learning and exploration, the Mars rover that's on its way to Mars right now, JPL used a AWS tool to teach the rover how to go around obstacles. So, I mean, we're already there. We're already doing these things. And so I would say that not only is AI and machine learning a game changer, but if you're not applying it, you're doing so at a significant risk to economic growth, health, safety, national security, across all of those things. So when we talk about at the beginning of this discussion about all the data coming in and trusted data sources and all of these things, to use all that data usefully, you have to find whatever those needles are in the haystack. So, I'll just use an anecdote here. Every meeting that I ever had in a situation room that dealt with a crisis of some sort, whether it was a natural disaster or humanitarian or a pandemic issue or a national security issue, every meeting started the exact same way with the exact same question. What do we know and what has happened? And those of us that have worked in the business, you get the intelligence community that says, we have the following, and we estimate with a medium level of confidence that this is what has happened. I'd like to get past the medium level of confidence and have at least a very good high probability data set that says this is what has happened. Now let's take it the next step and think about something that would blow everybody's mind at a decision maker level, right? The decision makers try to make decisions based on a limited amount of information, a limited amount of data. What I think the question that they all really want to answer is what is going to happen. And I think AI and ML can tell you with some level of probability what is going to happen. And that, for me, having to brief the president or brief somebody else, sir, this is what the data shows and this is what we think could happen with this pandemic or this, that's a huge game changer for public safety, security, for economics, all the rest. So don't fail to utilize AI and ML at your own risk.
Very well said, and I think you hit the nail on the head that both we're going to see a capability of when something happens or something goes boom, we can go back and do the equivalent of roll the tape, see what we saw then, but also have real-time awareness of the present, and like you said, even more importantly, pivot to the future and say, here's what the trends might lead us to. So I guess, Peter, I guess if I could ask you one additional question on this, how do governments get ready? I mean, we've seen stats that say, and I had my own experience where I did move back in 2015 an entire government agency to the cloud, but the stats are still only 11% of government agencies are in the cloud. So how do we accelerate that? Is this something that we need to have the new administration in the first year make a push, not just about moving to cloud services here on the ground, but start thinking about this? I mean, what would be, if you could wave your magic wand for the day, how would you recommend that we think about taking this on?
Yeah, no, it's a great question because I think all of us at different times have all been inside the machine, the slow churning, glacier of bureaucracy. But I think one of the answers, and we have deployed magic wands elsewhere around the globe. There are countries, like take Greece, for example, that have put in legislation, we are cloud first. Mm-hmm. So if you're going to do any new IT things, you're going to the cloud first. And so the more and more we, if we're talking about the U.S. specifically, I think as we start to work with agencies like USAID or HHS or parts of the DoD with the combatant commands, I'm sure U.S. Space Force will be an early adopter of new technologies. Let's show some early successes and show what can happen when we truly utilize cloud and AI and ML, because the U.S. bureaucracy is a completely different outlier when it comes to other governments. Right. But again, I think the more we can do on education and show the true benefit of what can happen to save lives, increase health, increase economic prosperity, these things, this isn't a sales job. This is where we need to go to help humanity.
Excellent. And real quick, Joe, I'd like to go to you. If you had to think about ways of showing what would be compelling demonstration projects that would make things go faster, in your opinion. I mean, you've also had the experience of working in the machine, and it's interesting. Sometimes it goes slow, and sometimes with the right leadership, it goes really fast. So what would be your take?
I think if we were to, from a DoD perspective, we were to look at things that I think are very important to us. I think kind of the LEOs, the low Earth orbit satellites that allow us to have very precise and pinpointed GPS navigation would be important for things like everything from hypersonics to I'm really thinking particularly in hypersonics and being able to pinpoint, or unmanned air vehicles, right? So UAVs, right? So we're talking about, we talked here about kind of the latency and some of the problems that we have with latency and the ability to get things like images, for instance, right? If I'm navigating something with an unmanned air vehicle and I want to be able to kind of take a look at what's going on, the ability to have something that gives me a consistent position and video from something like an LEO is something that I think would put us over the bar, right? So that I think the DoD would buy into that, because you're now giving me a capability that I do not already have, on top of the fact that I'm able to track something, coming in or going out, whether it's a deterrent or us, protecting ourselves, would put us over the edge. And I think that ability does come from, like we talked about before, the cloud and some of the things that are coming in from IoT-based infrastructures.
Excellent. Well, thank you, Joe. So now we're getting towards the end, but I want to go to Clint and then to Peter, Divya, and Joe. One, how do we start thinking about possibly multi-nation collaborations? Whether it's NATO, whether it's the transatlantic, or maybe it's even our partners, say overseas, U.S. and India, given that India is the largest democracy and we are the oldest. Clint, I'd be interested in your thoughts about how can multiple nations start to collaborate here?
Yeah, that's a great question. And, even as we think right now today of the International Space Station, so here we are 20 years of operating the International Space Station. Think about it. Continuous human habitation off our planet for 20 consecutive years. And there were some 15 odd nations that participated in the International Space Station. And so we have more opportunities like that in the future. Peter mentioned a few minutes ago, NASA, JPL has the Mars rover on the way back to the Mars. It'll be there in February of 2021 with the Perseverance rover. So here's the model that NASA is operating today. As the rover moves around the planet, it is going to take samples and take pictures. It's going to beam all of that data back to the Earth, and it'll be processed here on the Earth, and it's going to come into the AWS system. It's going to be deployed globally around the world in real time. And teams of scientists all over the world in real time are going to action the data, analyze the data, and then upload the next command to the rover about where to go and what to do based on that data that they just analyzed. We're going to do that all in 10 minutes, which is 3 times faster than we're able to do in 2012 when the last rover. And so teams of international scientists available to get data in real time from Mars, simultaneously action and analyze it together through disparate locations all over the planet, and then upload it back to Mars is really fascinating. And so the fact that the cloud is everywhere simultaneously really allows you to collaborate in ways that we've done that we just haven't been able to do in the past. The other thing I want to mention briefly is we talked about computing at the edge. And so I want us to think about computing at the edge typically meant being able to operate in remote or disconnected locations, right? There are no more remote or disconnected locations than space. But that is changing as we get more and more compute capabilities on orbit through size, weight, and power improvements, and we can put more powerful computing systems on orbit. We are actually moving towards an age where we can do cloud computing from or in space, or from the surface of the moon, or from the surface of Mars. And so that's really exciting because we will get to a point where we don't have the latency or the bandwidth to move everything from space back to the Earth, analyze it like we're doing with Perseverance, and then push it back to space. We're going to have to do that in space, and that means we have to have the cloud in space.
Fascinating. And maybe as a real quick rejoinder on that, Clint, I mean, it's my understanding that for the last decade or so, and maybe even longer, probes that have been launched, they have been launched with the idea of doing some adjusted version of TCP/IP so that we can essentially start building the internet in space. But I'd be interested in your perspective. I mean, obviously Amazon's leading the way. What does 5 or 10 years look like if we start talking about an internet in space?
Yeah, if we do it right, and it goes back to standards and applications. Divya talked, at the very beginning about data not being able to communicate with itself. And so as an example, AWS is part of the Open Geospatial Consortium. It's a worldwide consortium of geospatial intelligence companies and organizations that build collaborative standards together so that we can share data at scale and be able to use it. And so we've got to do more of those things. But I absolutely agree, in the future, if we're going to get to an Internet of Things capability in the space the way we have it terrestrially here today, we're going to have to do more edge computing. We're going to have to do more application standards.
Excellent. Thank you. All right, Peter. So your take, if you could sort of be president, prime minister for the day, secretary general of the United Nations, what would be some demonstration projects you'd like to see different nations trying to work towards that actually leverage what this provides us now in terms of capabilities?
Yeah, well, I would hate to see what happened that we went that far down the order of precedence that I am now in charge, but leave that nightmare scenario for another time. So, from a policy and government perspective, I think there's a lot of things going on that we are able to tie some disparate things together. Divya talked really in depth and well about trust and data at rest and transmitting data that we trust. But then at the same time talked about trying to keep the data secure and how we do those things. And sometimes security and transparency are at odds. And I think with what we're doing with the cloud, we've gotten rid of that. We can do both things. So from a policy perspective, let's look at some things that are happening right now. So we're talking about going to the moon. Too big of a thing to do alone. So the US is doing it with many partners. As part of that, they said, okay, there's going to be a way that we're going to get to the moon together, and that's called the Artemis Accords. So the nations that are involved in going to the moon have signed the Artemis Accords. To get way down in the weeds for just a second and super wonky, which I love to do, Section 5 of the Artemis Accords is titled interoperability. So it explicitly states if you're going to the moon, we need to figure out a way to make sure that our components work together, that we share data for scientific reasons, we're able to share everything. And so again, if we're talking about all this data that's going to be transmitted, Clint just brought up the good example of what's happening with the Mars rover. These things are going to be happening all over the moon, on the way to the moon and elsewhere. So we need to have a way to do that. And so the government's already instituting those types of things. The other thing is on the security thing. So the White House put out a executive order called SPD 5, Space Policy Directive 5, called cybersecurity. Very simple. It says you need to have good cyber hygiene if you're going to plug into the space network. If you have space capabilities, you need to get good cyber hygiene. the U.S. government and industry, which is important. The U.S. government and industry are going to work together to develop how we put this together. So again, if, you know, all the points that Divya brought up, the cloud allows you to trust data. We currently have the capability to operate at a secret level, at TS level. We have the ability to process HIPAA data. So we can do these things. We can actually have our cake and eat it too this way.
Excellent, and I really like the perspective you were painting, which is we seem to have been learning some from what happened in the past, so that we can make sure when we go to the moon, we're thinking about interoperability from the start, as opposed to trying to do it after this fact. And like you said, by working towards both data that's useful, we also have baked in security, and so we're actually achieving both sides of the coin. We now know that it can be used appropriately by the right people, but at the same time, we've also secured it. And so that's a really optimistic picture. And I guess, yeah. Peter, one real quick rejoinder on that is paint your picture for what 2025 looks like if we've accelerated from where we are here. What does the world look like?
Oh goodness! I mean, I think if we fully utilize these tools, we are responding much quicker and preventing the amount of damage that we saw earlier in the year in the Pacific Northwest and Australia. You know, and I think, you know, our colleague from Fireball has discussed that, and we'll talk about this some more. I think, you know, pandemic responses. I hate to say it, but I think COVID-19 is not the last time we'll see something like this. So for data tracking and be able to stop things as quickly as possible, I think will be critically important going forward. And then just from an economic standpoint, you know, chain of custody, seeing supply chains, those types of things will be extremely valuable. And I look at agriculture, and we're doing a number of things in Africa and in Asia and Latin America and elsewhere, where we're trying to work with local economies to increase the capacity at which we're able to feed people and take care of people. So my hope is in 2025, we are a safer place, a healthier place, and people are taken care of from both a, you know, health standpoint as well as a financial standpoint. So it's
Excellent.
Hard to be an optimist in DC, but here I am.
We're glad you're here. I mean, that's why we're glad you're here, and that's, I think, what the Atlantic Council stands for. And I was smiling because I want to give thanks to both you and Clint in particular, because it was back in 1995, I actually got called down to the principal's office and was offered a job where they said, would you like to have a job? I was 17 at the time. You just can't tell your parents what you're doing. And I said, yes. Turned out it was working for the Ballistic Missile Defense Organization. I was good with computers, and they wanted to figure out, one, could we pick up crop growth from space? And we showed that we were able to successfully do crop growth from space. And then the other one was picking up forest fires from space. And that could not be declassified at the time, but now it's amazing how this can now be talked about in a commercial setting as capabilities that folks can use. I'm going to circle back to Paul. And now, Paul, talk to me a little bit more about where do you see this taking us with these transformative capabilities and what you're doing with your company. Describe what the world of 2025 looks like if we've sort of extrapolated what you're doing and we thought about maybe integrating algorithms and possibly machine learning. What would 2025 look like in terms of transformative, positive applications?
Yeah, so 2025 is looking like super encouraging. We're doing a lot of work at the moment, as you mentioned, in the world of machine learning and AI. We're actually looking to develop a new camera network in Australia, which actually has machine learning on the edge, specifically for fire detection. So deploying our models that we run on our back-end infrastructure at those edge compute locations so that we can more rapidly get more content. But also, currently, as with most services, a lot of the data is actually still sitting on servers behind the scenes. You know, we prepare a selected set of what our customers ask for, but you know, there's so much more that you can do. So what we want to see is that because there's such a small proportion of information being delivered to people in the field, we want to start using cloud services even more. We know that they can scale and process a tremendous amount of information very fast. So we want to deliver this information to actually mobile devices for the field users. So, you know, it gets it into their hand really, you know, in a matter of minutes. As I mentioned before, we're getting satellite imagery directly from the satellite, and it's on our desktop viewable within 5 minutes. We know the capabilities there. We just need to start bringing into more processing of mobile optimized stuff. such as mentioned as the cloud optimized or cloud native formats, assist greatly in that way. But of course, for this to be a tool for first responders, it needs to be highly available, and it needs to be a trusted source. That we can't have it going down in the field when they're relying on it to put out a fire. So, having that fully backed cloud services that we know it's just going to stay up. It's a global coverage. It's just a great thing, and bringing all these things together is just going to deliver a tremendous outcome for the community, I think, in dealing with wildfires.
Excellent, and it's amazing to me because in a past life, this was in the mid-90s, 1995, I actually got pulled into an interesting Department of Defense project that was first trying to see if we could use military satellites to pick up crop growth from space for civilian purposes to try and pick famines up in advance, so we could actually see if there was not enough food being grown. And then later I got to lead a project that actually was trying to pick up forest fires from space, scanning the wind conditions and the topography and try to predict where they would go. But the limitation at the time was we were trying to use SGI machines, silicon graphics machines, and crays, and they just could not compute fast enough. And so I think that demonstrates where we are now is, one, that this is now commercially available, so it's not a classified project, and two, that we do have enough computing cycles. And you're right, Paul. I mean, I guess, could you maybe give me some thoughts real quick before I go to Fang about what might be some ways we can get this in a reliable, is this going to be something they're going to have it on a tablet in the field? Is it going to be ruggedized? I mean, how can this, or is it something that's going to be maybe even just talking to them in their ears and saying, just be aware there's something over here? I mean, what are your thoughts about how you make this relevant to the first responders?
Yeah, look, there's so many mobile devices, as we know, in the world today. They're highly powerful things. We don't need ruggedized stuff. We just need it in the mass hands of everyone to be able to see what's going on. So, following a lot of the standard cloud technologies and delivery, that's been well tested already so far. It's just augmenting it with this additional information that's, as fast as we can get it to them. And something that they can rely on as I said, as a trusted source, so they can make those decisions.
Excellent. It's all about expediency and having it be trusted. So Fang, I'd ask you the same question. 2025, you're working in Africa. If you could think both Africa and globally, what might be some of the things that we see 5 years from now based on what you're seeing and what you might be predicting for the future ahead?
So 2025, well, what we are aiming to do is, through our program, we'll be doing a lot of capacity building in Africa, and building awareness of the capability of the Earth observation as well, so that I hope by then a lot of the communities and industry in Africa will be able to pick up and really add value to the data and kind of service we provide. And globally, I think, like in general, I think the potential of the Earth observation data sets and the power of combining that with the additional data set that's just mentioned will be much widely recognized, and that will drive more innovation on top of that. And there will be unimaginable things that will happen by then.
Excellent. I look forward to, maybe we can have like a public space palooza or something like that, where we actually talk about what can be done here. All right, so now I'm going to pivot. I'm going to go first to Fang and then to Paul. This is now, you get to pretend you are UN Secretary General for the day, and you get to think about what you might encourage different nations to do to start to collaborate. And I realize, Fang, you're already doing it to some degree in Africa, but if you were to think about transnational collaborations for good, what would you do if you were Secretary General for the day in terms of your recommendation? I'll go first to Fang and then to Paul.
Oh, wow. Well, as you said, we are already building one shared platform where data and infrastructure can be shared between many different countries. And of course, the power comes in when the countries start to use it. So I would encourage the countries to work together to use it. And actually, it's in a country's interest to have access to data beyond the border, because the resources, a lot of the natural resources are shared, and the climate zones don't stop at the country boundary. And of course, the satellite observations don't stop at the boundary either. So by doing all of these together, we have one copy of the data that can be used by all people, that actually saves individual a lot of resources to develop and maintain such capability. And I think the other thing we try to do, and there's a great opportunity, is for this to enable and empower business or the private sector to really turn these data and products into more services. So, for example, the tailored information product about pasture or crop health to the hands of individual farmers. And if such tools are created on a common platform, they can be more transferable, they can be adapted to work across countries or continent. So really, if you make it easy for business to work across countries more easily, then you will be able to share the technology, the benefit of the technology, and also help cross-pollinate the ideas and draw more talents into developing more solutions. So I think that's where you can all work together to improve.
Excellent. I think I really like that image you shared, which is, the challenges we face don't stop at borders, but that also means the possible solution set and the innovation needed to solve it should truly be across borders as well. So thank you for that, Fang. Paul, you're same. You get to be Secretary General for the day. What would you do to encourage, and what would you see as great things that nations could do in this space collaborating together?
Yeah, thanks for that, David. So at Fireball International, we're basically there for the community. I mean, we all joined the company as a strong desire to work in that emergency tech space because we wanted a community good to come out of all of this sort of stuff. So, and we've actually taken some steps in this regard. So, we're actually really excited because in 2022 we're launching our own satellite. It's an Australian designed, built, and it's actually going to be launched in Australia as well. So. Super exciting, and it's specifically for fire detection. So what we found is that some satellites are geostationary, so they're positioned over certain areas that are known for fires, but other areas miss out. So this satellite will actually be a polar orbiting satellite, so we'll get full global coverage, and it'll be able to give everyone equal access to this information and a consistent way of viewing it so that the analytics that flow from that is the same no matter where the fire is. So I'm really looking forward to, seeing that rocket launch off and our satellite start spinning around the Earth, capturing this information. I think it'd be great.
Excellent. Well, you have to let us know when it is so we can also join you, because I agree. It's always amazing to actually get up there. Excellent. So now for the final round, we're now at what we call the lightning round. And this is where I ask each of you to give 2 to 3 tweet links. So we're looking for fairly short recommendations in terms of action steps forward you'd like to see in the world. I'm going to go first to Fang and then Paul to close. 2 to 3, again, recommendations. Fang, what would you recommend in terms of action steps we can do forward to make a better world using cloud-based services and space capabilities?
So I think the first thing I would say is we all need to educate ourselves and continuously educate ourselves to really keep up with the technology and adapt to the rapidly evolving technology. And this is not just about understand the technical complexity, but also be mindful of the ethical issues that might rise with these. And the next thing is focus on the problems. So these new technologies are very exciting, but they really need to be integrated into solutions to all these problems that we're trying to solve. So, how to increase food security, look at how to improve gender equality, which is very, very dear to my heart, how to empower women with the use of technology and in the use of technology. So these are all the things that we need to think very hard about. And also in Digital as Africa, we're certainly trying very hard to make sure that we would have the real impact in these areas. And finally, there is a vast amount of data that's available. In order to realize the full potential of it, this is beyond any one of us, so we really need to work together. So to partner up with open minds, and of course, we're always open to talk to you if you have an idea that we can work together on.
Excellent. And I really like what you said in that, we have to recognize we should always be learning and also be thinking about the ethics here. We should make sure we are problem focused in what we're trying to solve, and then partnering as a way to move forward. So now, Paul, your chance to give 2 to 3 tweet links, action steps that you would also recommend here.
Yeah, so based upon that partnering idea, where a similar mindset is that, we realize AWS has done like an exceptional job with that open data platform that they have. And the data that's there is great for the whole research side of things and getting access to vast amounts of information. but we'd like that extended to allow rapid sharing of more raw information from satellites. So not everyone needs an antenna in their backyard to pick that up, but get that source down once in a cloud environment, and then fan that out to all these people that want to consume it and do their special parts of intelligence or whatever they choose to do on that. But it does need to be more precise in terms of how frequently, for businesses to rely upon this as a true data source for them. It needs to be a little bit more strict on its delivery, not so vague. So, but a great first step, but we can extend it further, I think. We'd also encourage leaders, just to educate themselves on the positive impact of all these technologies, and then go and foster that and promote that into their communities so that, we can get that groundswell of people that, are really excited just as we are on the future that's coming.
Terrific. And I liked how you said, let's think about how we make sure it's more connected and relevant, and then also think about the groundswell of getting the communities involved. All right, so Divya and Joe, and then we'll go to the lightning round after that. Divya, you get to be Prime Minister for the day or Secretary General. What would be demonstration projects you would want? And then Joe, I'm going to ask you the same question.
Wow. President or Prime Minister for the day. Well, I feel the same way, kind of humbled. I don't know what would have happened in the whole chain of command to make me President or Prime Minister for the day. But I just want to say I kind of love the fact that everybody is alluding to space. Space is actually the place, I believe, that the most ultimate international collaboration started. I mean, the US and the former Soviet Union were collaborating during the Cold War to open space. And that, to me, when I was a kid, that was the most amazing thing I had ever seen. The mention of the Artemis Accords, it's funny you mentioned that, Peter, because I just attended a space law symposium, and that's where I learned about Section 5 and the interoperability. And, if somebody has a USB-C and somebody else is using like a USB-A port and your equipment can't talk to each other, that would really suck. It really brings home that we are sort of in this sort of connected global human family. And I would say that in terms of how we would spread this to promote international cooperation, well, scientists have always loved sharing data. They just would jump on this. Public health officials have been trying to do this, WHO, USAID, and their projects like PREDICT, and to create these sort of global efforts to both be on the ground, but to integrate this data more centrally so that they could do future pandemic prevention and prediction. Climate change is another one. I think, Peter, you might have mentioned natural disasters, food security, water and sanitation. Another one I actually wanted to mention was human migration. We have a huge problem actually with displaced people on this planet. And they're not often claimed by nation states, and they're still part of our family. And not only do they deal with all these insecurities, using cloud-based technologies to help them develop digital identities so that they can actually move through the world and be recognized and be protected is another possible application of this, and a place where we can come together as a global community. And so for my part, I just wanted to end by saying that the trust and the interoperability are the two biggest issues. So whatever type of network architecture we build, we need to be able to support this on a planetary scale.
Excellent. And it sounds like what we may almost need is maybe in 2021, we do an event that's public space entrepreneurship and thinking about, both civic action that we can do, and I think maybe we need a Space-a-Palooza or something like that. So with that, Joe, your chance to be President or Prime Minister for the day, and then we'll go to the lightning round after that. What would you do? And you got to unmute yourself.
Sorry about that. Wow. So like everyone else, I'd be humbled. I'd be concerned. It was all up to me, but I think I'm going to hit 2 points. One of them that I really like that Divya brought up is kind of this interoperability. As you know, David, I worked with USAID on the Ebola response, and the biggest problem we had was, as people went from one state to the next, their information didn't go with them, and we were unable to track them. We were unable to figure out what was going on with them. So I think interoperability and transparency in the data alludes to trust, as we've always talked about, as we've talked about the Geotech Center, that allows us to really ensure that the data that we get, we can do some sense making and make a decision from that. But if I were, I would say if I were president for a day, I think my biggest goal would be bridging the digital divide, right? So I think that we need to bring people onto the internet. I think LEO has the ability to bring people in very far reach places across the planet, give them internet, give them access to digital finance and digital health, and give them access to the things that they don't currently have. So just overall uplifting the human persona and uplifting their stance and where they are. And I think that if we were able to do that effectively and efficiently, and trust the data, as we said, and it's interoperable, we'd have a society where everybody was connected and interconnected and able to talk and able to understand, able to track these things that we've talked about before. So that would be kind of my vote for me.
Well said, and I like how it's two-way. It's not just what can we observe from space, but what can space do to help actually connect the unconnected as well. So now we're going to go to lightning round. I'm going to go to Joe, Divya, Peter, and then Clint for the close. This is your chance to give 2 to 3 action steps that we should take from this. And so, Joe, I'll go to you first. And was interested in your thoughts. What would be tweet-size recommendations? So we're looking for short 2 to 3 steps that we should take from this in terms of next steps forward.
Well, I won't steal the lightning that everyone has already said, but I think trusting the data, understanding that there's going to be trust between, which means you have to have transparent data that's interoperable. So we kind of said we said it already here, but those 3 things I think are the most important things to drive the data for decision making. If we can trust that data, we can make an effective decision that we've encompassed all of the parties involved.
Excellent. I like that. Trust, transparency, interoperability leads to effective decision making. So thank you, Joe. Divya, your chance to give your 2 to 3 tweet links recommendations of action steps. Oh, and you're muted as well.
Sorry.
No worries.
So to some extent, I'm going to agree with Joe. Maybe I can throw in something else. We're talking about all of this in the context of space. Space is the place that we first went to actually see our own planet and have it reflected back to us, to recognize that we all live on this sort of spaceship, this fragile ball that we call planet Earth that has no borders. Some people have described this as the overview effect. A lot of astronauts actually undergo this kind of almost a spiritual transformation. And I would actually like to bring that back to the rest of the planet, remind them about how interconnected we are so that we can bring together all these communities like we see on this particular call to actually build a trust and data sharing network where we don't violate the planet's trust and just really remember our shared humanity.
Very well said. And you were talking about how that iconic image that came back from the moon of our planet, I believe that's actually one of those photos was less than a year later, gave birth to both NOAA, the National Oceanographic and Atmospheric Administration, as well as the EPA. So the question is, what new images of our planet might trigger new ways of working, whether they be agencies or organizations or coalitions and networks? So very well said, Divya. Peter, your 2 to 3 action steps that you would recommend that we do.
Yeah, so I have 1 ask and 2 demands that if I was a policymaker, I would put in there. So the first ask is, educate me, tell me how I can utilize cloud, compute, AI, ML to solve the problems that I currently have. What can you all do for me? And so from the AWS perspective, there are myriad tools. And the way most of those tools were developed, 90% of the tools were actually customer asks. Can you do this for me? The other 10% were actually inferred from, well, the customer wants to do this, why don't we build that? So just ask. Trust me, it's possible. The other 2 demands is that when you get the answers as to how you go and do this, the number 1 demand should be make it secure at the outset. Make sure that we can keep the thing secure. And the number 2 demand is make sure that it's interoperable, that I can plug and play where I need to plug and play. What can you do? Make it secure and make it interoperable. That's it.
Excellent. Very, very well said. I really do like what can you do? And like you said, let's make sure security is from the start. It's not an afterthought, and also make it interoperable. That will lead to a better future ahead. All right. So Clint, you get to bring it home for us with the final close.
Great.
What would you recommend?
Great. So I would say, look, to fully leverage space and to maximize the promise that I think it offers in shaping the future in a positive way for all the things we described, humanitarian relief, agriculture, maritime, any other application. And by the way, innovators will surprise us in ways they will use space data as long as we make it available to them. But to fully leverage space in the way that it can offer the greatest promise, we have to move the space enterprise to the cloud. That's my first and foremost thesis. The space industry, for as high tech as it is, and I've been in it for 30 years, I will tell you in some ways has been slow to embrace the cloud the way other sectors have, potentially like the financial services sector. So that would be point number one. We're only going to achieve the future promise that we want if we move the space enterprise to the cloud. And the second that we haven't talked about today that I think is absolutely critical, and that's developing enough trained workers who know how to operate the cloud, manage the cloud, and build applications on the cloud, right? Most of these kind of panels, we ended up talking about the critical skills shortage. So knowing that this is the future, we are going to have to invest. We do that in AWS. We have other programs and capabilities to help other companies do that. But we're going to have to invest in developing the kind of workers with the right kind of skills to continue to optimize the cloud moving forward.
Excellent. Well, I think you hit the nail on the head, and I really appreciate you touching on the talent part. That does sound like maybe we need to have a future conversation later. How do we actually bring that in? Is it a case where maybe we need to think about, just like how there's the reservist model already for the military, do we need to have a civilian reservist corps that's actually people that might be working in space, but are also maybe contributing 2 to 3 days a month or something like that? There's a lot of interesting ideas in the talent space, and with the Geotech Commission, more formally known as the Commission on the Geopolitical Impacts of New Technologies and Data, I know we're looking forward to putting recommendations about talent for 2021 onwards. So with that said, I want to give thanks to Divya, Clint, Peter, Joe, Paul, and Fang. Really appreciate these discussions that we've had here today, and I hope to continue these conversations as we think about how we can use space for public good and cooperation globally.